So my name's Shaun Howell, and I'm from Cardiff University. I've spent the last 3 years investigating the role and the value of semantic technologies and their application in Internet of Things and artificial intelligence purposes. Some of the outcomes of my work are intended to be a smart city ontology, which should gather all of the objects and relationships in this domain in a way that's machine interpretable, a semantic web framework, so a semantic web of things software platform, which aims to then interoperate and integrate software and data in the domain, and a number of different learning outcomes. So on with the show. Very simple content, so I'm going to give you a bit of background about the work that we do at Cardiff and the role of this challenge that I'm trying to solve, then go on to the work conducted and some outputs with a focus on my work in the smart water field through a project called Wisdom. And then I'll go on to the discussion, talk about how I've done this work and some of the learning outcomes and the impact that come from this. So future cities have a wide range of new emerging technologies available to them that they can leverage to improve their systems and their efficiency, such as advanced batteries, 3D printing, and biotechnology. All of these amazing new technologies. Two of the ones which have, at the moment, the most hype and possibly the most potential for improving system management and the performance of operational systems are artificial intelligence and machine-to-machine communication. This is the area that I focused on. But going from this hype, looking beyond this, what value does this actually bring to stakeholders in this domain? How should these systems be used? How can these come together? And who does this bring value to? So these are the kind of questions that I've been trying to solve. For example, if we look at the water domain, because water has recently been upgraded to the biggest global risk over the next 10 years by the World Economic Forum. In the water domain in the UK, some of the challenges are increasing water demand and demand intensity as well through urbanisation. And there's a critical need to manage the rising capital costs, the capital expenditure of building new networks. So smart technologies offer a really promising way to improve the efficiencies of these systems and avoid building new infrastructure. This leads to some opportunities such as smart metering, which can allow you to do demand-optimized management so that you better match the demand and the supply side of your value chain. And by intelligently managing the pressure in your network, you can improve the lifespan of your aging pipes and also reduce leakage and therefore reduce non-revenue water, which is a really big problem in the water industry. Smart water, as well as other smart domains like smart grid, all at the moment tend to be relying on Internet of Things and artificial intelligence. So these are really big growth markets. Internet of Things is at the moment about 8.5 billion globally, according to Markets. And over the next 5 years, it's set to more than double. So this is a very big market. And artificial intelligence is going to increase supposedly by more than $10 billion up to 2019. So there's a lot of interest in this area, and there's a lot of money going into this, but there's a problem, and that's interoperability. It's been said that 40 to 60% of the value of these markets can only be unlocked for the stakeholders if you have this seamless and pervasive interoperability in Internet of Things systems. And I would suggest that if we want to use Internet of Things to fuel artificial intelligence, that it's going to be the same or even more important to have this interoperability in IoT AI applications. This interoperability means common communication protocols like Wi-Fi, which we all know, but even more than that, it means new technologies such as semantic technologies. So once these things, these devices and software resources can communicate to each other, they then need to be able to understand the context and the meaning of the data that they're actually sharing. And this is where semantic interoperability comes in. So I've prepared a brief video to try and say a bit more about this and introduce the role of these technologies.
The built environment is being revolutionized by smart technology. Wireless devices and advanced software are improving the way in which we manage energy, water, transport, and other smart domains. The Internet of Things is helping to connect all of these resources, but allowing them to talk to each other doesn't mean that they are communicating effectively. If they send data using different words and meanings, they won't be able to interoperate. This is where semantics come in. By using standardized semantic models, the resources have a framework for aligning their semantics. This allows them to work together in complex applications, supported by a powerful web of things. Therefore, semantic models describe the terminology, metadata, meaning, and logic used in a domain.
So that's kind of an introduction to the role of semantics in terms of Internet of Things. But we can frame this gap from another perspective if we look at the value derived by businesses from these Internet of Things systems. So this is a typical Internet of Things technology stack where data flows from the bottom, from the physical things, the sensors in the network, up to the business processes and the users that are engaged in those. As well as this, there's the long-standing business intelligence value concepts. So this is well understood within business. How do we go from data, just numbers, up to actionable intelligence, which is termed here as wisdom? And as an example of this, we could say that data might just be a number. So in the instance of a pipe blockage or something, data might just be 3. Information might then be 3 meters. Knowledge could be 3-meter pressure head, which is too high. And wisdom would be, oh, this is too high, therefore you need to shut down the pumps and you need to send someone to go and fix this. So this is well understood within business intelligence field, but at the moment there's this big gap between Internet of Things and business intelligence and the value that you can get from these systems. At the moment, there's too many dashboards sharing data and not enough real insight from these systems. So what have I done to try and fix this through semantic technologies? Well, I've spent the last 3 years doing action research, investigating these technologies alongside expert organizations. These shows a few of them. By engaging with a wide range of stakeholders, I've managed to get this broad evidence base from a number of different perspectives. And this occurred within the context of 6 different research projects. And by engaging with these formal research projects and all these different organizations, I managed to gain this deep understanding of the technologies and how they work together. So to quickly talk about the projects that I've been on. NHOLIM, Knowledge-Based Holistic Energy Management. This aimed to optimize the energy consumption of public buildings through a retrofit building energy management system through artificial intelligence, IoT, and integrating this through a semantic web approach. Resilient then increased the scale of this to multiple public buildings within a polygeneration microgrid, so also looking at district heating and cooling. Then mastering, on the domestic side, aimed to optimize the demand profiles of a residential district through intelligent load scheduling and also introduce new market actors for in the flexibility market. Wisdom then took this energy concept into the water domain and looked at similar things but on the water side. And through my work on Wisdom, I got involved in another project called Hypercat, which is an Internet of Things project, and it's proposed a standard for IoT application layer interoperability. Beyond these projects, then, my contribution was to try and unify all of this into one semantic framework, one ontology which could be generalized across these, and one set of software and best practice principles which could try and bring all of this together. And once we'd done all of this work, this then served to be the underpinning backbone for Cardiff's ongoing quest for a single computational urban sustainability platform that brings together this back end with powerful data analytics and 3D visualization, which I'll show you in a minute. So some of the outputs. NHOLIM, the first project that I was on, went really well, and that's now finished, and this produced a retrofit building energy management system, which in testing managed to save about 25% of the energy consumption of this building. So that went well. The Computational Urban Sustainability Platform, this is also going really well. So I did some laser scanning of this pilot site, and these were then converted by the amazing Cardiff team over here into IFC objects, and these are then shown through a browser within the Unity game engine. And you can see this here, and we can pan around and we can click on these, we can get details about the IFC properties of those, as well as an interface to the analytics engine and the optimization engine on the side there. So by allowing you to see this optimization engine graphically, it allows more engaging decision support, and it also provides richer, more deep insights because it provides suggestions about how you should change the generation unit set points rather than just saying you've used a lot of energy in the last week. Now, just to focus on smart water, because this is the project which I've been most involved in. The Wisdom project produced a semantic cloud platform which integrated a wide range of data sources from the water domain into this cloud platform and then pushed that out the other side to a number of value-added business services such as system optimization, operational decision support, and in-home displays. So this is the system architecture of the solution. Data flows from the bottom, from the data sources up to the users and the business services at the top. You can see that as data is passed to the cloud from the event bus, it then goes into this knowledge management service, and this is where most of my involvement was, my contribution. So the triple store stores all of the static and semantic description of the network, so it stores the GIS data and also information about the relationships between all of the objects there, so that you can build these more advanced artificial intelligence services on top, and then push that out through an API to business services which are consumer-facing. And that consumer then might be an in-home display, so it might be a domestic consumer, or it might be a decision maker in the water value chain in a water utility company. This ontology, which I made, which is stored in the triple store, is one of the main contributions of this project, because this addresses the semantic water gap, semantic interoperability in the water chain. So I'll say a quick bit about that now. The water value chain, we modeled it through the physical artifacts, going from abstraction from natural resources through to consumption in homes, and then back out the other side of the wastewater network through to discharge. And this was modeled as a number of different nodes and links. So these nodes might be treatment work or a house or a reservoir, etc. Then as well as the physical artifacts and full descriptions of these from enhanced GIS schemas, we also then modeled the sensors. So we described the water meters, the pressure meters, etc. And then their relationships to the water network to contextualize the data that came from them. Even further, then the semantics of the metadata from this. So metadata is just another type of data. And again, you need to know the semantics. If we say how frequently this measurement was observed, what unit of measurement are you using for frequency? So again, there's this deep, rich semantic picture being built up. And then as well, social entities. So we described the actors in the water value chain and their obligations to the water value chain and their responsibilities, and then also the governance relationships between those. So you get this rich picture built up of the water value chain in a way that's machine interpretable. And because we did all of this work making this rich picture machine interpretable, it was then really simple to build these GIS systems on top of that data, on top of that platform. So we were able to integrate different systems which at the moment are siloed within water utilities, like the GIS data and the dynamic data, as you can see here. And even further, I then took this further to actually do artificial intelligence over this. So with a use case of fault response to a pipe burst, for example, you can see where the fault is, and then semantic inference manages to tell you where all of the affected assets are. So it shows you all of the downstream assets which are affected. And it can also tell you more interesting details like the severity of the problem, when it occurred, and the number of affected customers, who the closest person is that can respond to this. And then it can link as well to the customer database. So if you wanted to automatically send out emails to the affected customers, again, it would be really simple to do that because you've exposed this rich interface of the data. So from this has been a number of different learning points, and I just want to share a couple of these quickly with you. I think I'm running out of time. So first of all, we're really lucky in the UK to have British standards, and British standards are incredibly active in this area. So it's been really useful to work on their standards and go beyond their standards to try to avoid reinventing the wheel, which is obviously a common thing that you want to avoid in research. So they've produced this smart city concept model, and this was the grounding for the smart city ontology which I produced. There's the PAS 212 automatic resource discovery for Internet of Things. So this allowed me to integrate my work with the Internet of Things field through automatic resource discovery and interoperability signposting. And then also as well, to the crowd here, I'm sure, building information modeling standards were incredibly important because this allowed me to see how the asset information model might relate to all of this in the operational phase of these assets. And therefore, I aligned my work with the industry foundation classes and the current British standards around BIM. Very quickly then, a couple of the recommendations that have come out of this work. On the technical side, the one which I want to pick up on quickly is it's really important to understand the strengths and weaknesses of semantic technology. A lot of people from the semantic technology community will kind of say that it's a silver bullet, that it'll solve all of your interoperability problems, but you really need to understand the data that you're dealing with and what you want to get from it. So you need to prioritize the requirements, and also you need to understand your data. So is your data big in terms of volume and velocity, or is it big in terms of variety, if you know what I mean by that? So in terms of the variety, if you've got lots of different data sources from different stakeholders and different businesses, from different domain perspectives, then semantic technologies are really good at integrating that. If you've got really high velocity data, so Twitter, for example, you've got data flying in all over the place, maybe it's not quite as strong and you need to try and mitigate against those weaknesses. From a business perspective then, I just want to advocate for start small, start smart. So I think it's really useful in a business context to try and get the low-hanging fruit first. So you choose the IoT intervention and the AI intervention, which is going to yield the biggest impact on your business for the least investment, obviously. But then also to start smart, so choose the technologies and the standards that are going to allow you to extend that in the future and also allow you to avoid affecting your business's usual processes and systems. For example, you can produce a layer above your legacy systems. Rather than replacing your relational databases, you can put this semantic layer above it through technologies like On Top or Virtuoso. So you can have this as like an additional extra, and then when you see that it goes well and it provides value, then if you've made those smart choices, you can scale it up. So I'm pleased to say that this work's been well received. The highlight of this is the Australian endorsement. So I was invited to publish a strategy paper by Internet of Things Alliance Australia, and this led to me recommending a standard, and that was then accepted by the Australian government and by Standards Australia. So I'm really pleased to have that under my belt. And that's everything.
Thank you.
Thanks very much.